Okay. Come on. Nah. I already listened to the song. I don't want to listen to it again for now. Okay, so... Okay. Sweet. Alright, so... live chat. Pop out the chat, and then of course I need to set it to live again. Hello, Noah. How's it going? Right. What else did I... Yeah, okay. So the stream's working now. Another thing I want to test. Yeah, no, Discord still takes forever to launch from the sys tray. That's good. How's your new, well, not new, I know you've been working on it for a while, but how's your AI thing going? With, like, your, Onyx AI, or Odin AI, I forgot what you called it. Why is that? I've been there. I like program a neural network in Python and just get bored of it. Part of it was I hate Python though. Anyway, I did do some programming off camera, and I I basically just wrote a bunch of boilerplate in the emulator. So, not anything too much off camera. Yeah, not like Minecraft off camera mining. Just some, like, boring boilerplate. And I know I do use AI on these streams, but I never use it to program. I never copy and paste AI code. The only thing I use AI for is figuring out how code works. Like, if you see me copy and paste AI code, then it's probably not me. Exactly. Like, people who use AI to program are, one, disingenuous, and two, just stupid. Okay, let's see, what did I do? Oh, wait. Did I, It's airing, and I don't think I put WAir on. Oh, I see why. Okay, so where did I leave off, though? Yeah, not even boilerplate. Like, I don't want any of my code written by AI. So really all the boilerplate I did is I added an enum with all the hardware interrupts in it. I added my flags and my special registers and my general purpose registers, or just registers in general. I added a timer struct with a ticker. I added my CPU, which stores a reference to the memory. And then I added functions for creating new CPU, advancing to the next instruction, and then executing the instruction, the biggest instruction size in bytes, yada yada yada. How I did flags? Oh, it's just booleans. I did not overthink it. I literally just did booleans. Why would I use unions? One, that's undefined behavior, especially when you start getting into endianness. And two, it's just like not a huge deal. This whole struct is 5 bytes big. Like, this whole struct is only a single byte bigger than an unsigned 32-bit number. I like unions when it comes to tagged unions, but not for weird things. I want this emulator to work. I want this emulator to work. That's why I'm not going to use unions and other weird crap for stuff like flags. Okay, CPU.c. So, let's see. Right, so CTX save. It will have... See, that's what I'm trying to figure out. I might add graphics, but it's not... Graphics are not going to be part of the specification for the CPU. What it's going to be is you're going to have graphics, but it's going to be more like QEMU, where you have to have a special driver in the operating system that interfaces with the emulator's graphics. So it'll be like the emulator just reads stuff from a certain memory chunk, and that's how you do the graphics, and then a driver interfaces with all that. Expose a frame buffer. Assuming a frame buffer is just like basic graphics, yeah. I also don't know how to handle this, which is a problem. It's, and yes, I'm using GoTo. Specifically to fuck with you, dear reader. But yeah, so the problem is, to trigger something that can trigger a hardware interrupt is when you try and access memory that doesn't physically exist. So if I have memory in an interrupt that physically doesn't exist, I don't know how to handle it. I guess just undefined behavior. And then CTX save, I've got CTX... I think I already did CTX load somewhere. I guess not. So what I need to do is I got CPU advance, I get the next instruction, K. Yeah. See, like I can't handle memory inside of trigger hardware interrupt because that would cause a potential cycle. CPU execute. I don't know. I haven't implemented RAM really yet. Right now I'm just prototyping to make sure I can actually get something that works. Yeah, so like right now, RAM is literally just 600 cells. And this is temporary. This is just so I can get an emulator up and running, and then I'll improve the entire thing. So, okay. I'm triggering interrupts if the memory doesn't physically exist, yada yada yada. And then when triggering an interrupt, I get the address for the next instruction. I get the address for the interrupt, and then the jump address to jump to for that interrupt. And then after I get the jump address, I save the CPU context, and then I just hope that I don't get a memory error. And I move on to the next, so I save the return point for the interrupt and the execution ring return, set the execution ring to kernel mode, and then I jump to the jump address. Yeah, saving the CPU registers and flags to memory. And there's a special register that dictates where to do that. So I guess I'll just write ctx save and load. Save CPU context. Static. I won't inline it. Static void ctx save. And ctx save will take a constant, so I'll take a const CPU restrict CPU, and it will take a int restrict memory error. Yeah. Wait, let me memory H. Right, so that's memory I mean, I try to inline stuff if I think it makes sense to inline it. And I also want to restrict all the other memory errors too, just so I can speed up the program. Oh, looks like I already did that. Cool. So this will be the restrict, this will be the ctx save, and this will be load CPU context, ctx load, and instead of a const CPU reference, I want a CPU reference. And, right, I guess, ooh, I know something that will help. I'll make a static const flag list. Static const flag list. It will be an array of Boolean pointers. All these CPU flags listed, pointers to CPU flag values listed in definition order, used by context saving loading functionality mainly. And then I'll have the same thing, but for registers. Pointers to CPU register to CPU registers. Register list, and I'll make a reg ptr struct, which will store that pointer information. Reg ptr. Actually, just be like that. And the first field will be a void pointer register ptr, and a register size pointer to register value, register size. Reg PTR, RP, RS, RP, RS. All right, let's make these lists. So I'm gonna pull up. How is multi-endian implemented in practice? I'm looking at it in terms of software compatibility between architectures. Like, think the OS can set a flag if a program is. Yes, so endianness, if you think about it, all it is how you're storing stuff in memory, like in what order that the save and load instructions should do the thing. So changing the endianness in my architecture is literally just changing the order in which the bytes are saved or loaded. That's it. It actually just works. Endianness is just a standardization. Right. Flags. I don't think these should be defined here. They should be, I'll make a new function. Hello, Resparring, how's it going? Need to make a new function. Here's what I'll do. I don't want to use global state. It's coming along. Okay, I won't use global state. No, it can't be a CPU. It can't be a CTX struct because there is no concept of a context structure. Oh, I know. Okay. Okay, I'll write some static functions. CTX save flag manual. CTX save flag manual. It'll be void. It'll take a const CPU restrict CPU int restrict memory air, and it will take address t offset. Save flag to context memory chunk with manual address byte offset from chunk start. let's see. I need to figure out what register did I use for the syscall context. Right, I called it context storage. Yep, CS, context storage. And right, so context storage, address T begin, CPU registers special context storage. Save me, Mario! Save me! Should I play it? No, so it's not, the context is not being saved in registers. The context is being saved to memory. The CS register just stores the beginning address of that memory. So begin, and then address store at. It'll be begin plus offset. And then I just have to I also want a memory error equals 0. Need to make sure that's also what I'm doing. Yep, in other places. Yep. Good. So memory error is 0. And then okay, I just realized I should specify how flags are stored in the context in my specification. I'll do that in a sec once I figure it out, though. Let's see. Byte index. Yeah. So, what I'll do is I will right, so first I need to read so int byte, I need to read memory read CPU memory physical address will be store at. Actually, you know what? So my initial idea was that 1 byte in the entirety of the saved context will be for all the flags, but I'm realizing that since reading and writing memory is actually quite slow, it won't be as space efficient, but it will be way faster to use 1 byte for each flag. And it's only a few extra bytes for like half the performance penalty, so I think that's what I'm going to do. So I'll get rid of this byte index parameter. Memory write. CPU memory. Physical address will be store at, and data will be I guess the flag value. Bool flag value. So there we go. Flag value. And then yeah, okay. So that will be how a flag is saved. And then I'll also write and I'll inline this. Inline. And now I'll create another function, and I also want to fix this up a little bit. Oh wait, this is C. There we go. So CTX save flag manual, and then I also need save register to context memory chunk with manual address byte offset from chunk start. And I want to static inline void CTX save register manual. I'm going to do const cp just copy all that, and then I want to change this to Oca64 register value and Oca8 register size. Yeah, there we go. And then I want to address T, want to get all this. And flag value will be, so I have this whole thing, and then what I want to do is for size for address ti is equal to 0, I is less than register size I plus plus. I'm going to do memory error is equal to memory write CPU memory store at plus I, and then I want byte, and I will do Oca8 byte is equal to, and then I just want to do some bit shifting and stuff. So I'll do I need to look at my specification. The order in which the CPU registers and flags are stored is part of this specification. all general purpose registers starting at register 0 and going up. C general purpose registers, all special registers in order that they have been declared in sections. Okay, all flags. Context saving. A CPU context save is where the CPU saves all registers and flags to the memory address inside the CS register and going upwards in memory address as the registers and flags are stored in positional order. Any multi-byte values, such as registers bigger than 1 byte, must be stored in little endian, despite how the CPU endianness is currently configured. Yeah, okay. A CPU context load is where the CPU loads all registers and flags into physical hardware, replacing the old values. Reverse process of saving. Right, so now I just have to get the little endian byte. So I need to do uint64t register value. Make sure it stays uint64t. Hello, Astra. How's it going? You finally made it. Right, so I need to get... oh, wait, this is actually super easy. I just need to uint 8t after and I. So first this will get the first byte, and then, yeah, so little endian, good. And I want to say if memory error is not equal or is less than 0, return. And I think I'm actually doing some other weird shenanigans with memory. Yeah, like this. Or wait, no, that's fine. Now, is that fine? Yeah, that's fine. Okay, looks like I was actually smart with this project. Okay, so, yeah, memory error. Memory write, so that's storing registers to RAM. And, now for the actual CTX save and CTX load. So, since I have instructions in my ISA for saving and loading individual registers and flags, or I think just individual registers, I do actually want to, write separate functionality for that too. Save CPU context register. Save CPU context only specific register. static void ctx save register. Yes. And then const CPU restrict CPU int memory error and I guess oh, I know how I can do this. Oh, hey, Ernest Perez. How's it going? See, you're new, but you only sent a period. Did you watch any of your ASMR VTubers today? No. CPU memory error. Right. So I can do something smart. I can do a void pointer to a void pointer to register. And the way this is going to work, yeah, I watch ASMR. I find it quite calming. And there's a VTuber with a very calming voice. I guess I could bring it up. This one. I don't know, like, I don't actually watch them, I just listen to them, but yeah, it's just calming stuff. Like, she'll talk about life or work or whatever, and it's just peaceful to listen to. And don't worry, I'm not that weird guy who's like listening to constant weird mouth sounds. Nope, not on NixOS. NixOS has mentally scarred me. I'm on Gen 2 right now, and to say the least, it is the best Linux experience I've ever had. So I don't see myself switching off Gen 2 anytime soon. Maddox, you also admitted that she has a nice voice, so I don't know. Switch. Switch register. Yeah, well, I'm also a lonely little boy in Austin, Texas. So can you blame me for going a little cuckoo? Okay, what? I just realized my method's not gonna work. See? So you essentially do the same thing as me. You just listen to videos with people with calming voices. Just so happens to be that the person I like the voice of the most currently is just a VTuber. Const, okay, so that's good too. CPU memory error const void. Oh, the package availability in Gen 2 is actually amazing. They got there's something called Guru. It's essentially the AUR but for Gen 2. Yeah, hey for my Wayland Racing video. Yeah, the package manager portage is written in Python, which I do eventually want to create my own Linux distribution, but it's Gen 2 is currently the best thing I use. So how do I want to... Okay, fuck it. Uint64T value No, but it's UN8T. Oh, shit. I don't ever want to use Emacs. I tried it once, hated it, and it's also not a terminal text editor. What was I gonna... Trying to figure out the best way to make reusable thing where... Yeah, I use a bin host. Oh, I know how I can do this. I'm gonna have an enum CPU register. Let's see, special registers enum. No, how do I want to do this? Oh, I know. Okay, here's what I'll do. Save register general purpose. Save CPU context only specific general purpose register. Oh, also, this is off topic. This is off topic, but I learned OpenGL. And it only took me 5 hours, and most of that time was just me playing around with the stuff I already knew. So in reality, it really only took me like an hour and a half to learn OpenGL enough to basically make whatever I want that's two-dimensional. My trick to that is instead of watching tons of tutorials, just fuck around and find out. Oh, that's weird. What? I guess that's what I get for dynamically linking. I do see it's masked. Sudo, let me just... system files, pkg, accept keywords, what was, EAX glue, media libs glue. So let's see if this will get me a newer version of glue. OpenGL didn't take me that long. Vulkan, though, was a fuck around and find out type framework, and I've heard people have brick their GPUs because of how much time Gentoo update take. For me, since I use bin hosts, a Gentoo update takes around 15 minutes at worst. See, like, this is purple, meaning I'm using the binary host. Boom, glue is done. See, that is interesting. I wonder why it failed to initialize. Also, why is it... Oh, that is interesting. Why would glue fail to initialize OpenGL? I'll figure this out later. I'm actually kind of glad it's happening because now I have another rabbit hole to go down. But anyway, yeah, I learned OpenGL. So, okay. Switch register. General purpose, and I want an enum, or actually an index. uint 8 gp reg. Thoughts on using AI to problem solve? Depends what you mean by that. If you mean asking AI to write code that you then copy and paste, no matter how much boilerplate it is or how little it is, then no. I despise people who do that. I despise people who pay for things like Copilot and pass off the code as their own and just freely do it. I hate how, like, the fact that we're at a point now where you either copy and paste code or like AI generate code and still call it's abominable. AI generated code is abominable. And the people who use that AI generated code in their projects are even more abominable. Now, using AI to surf the entire internet in just one little search, that I'm all for. I use AI all the time to ask it what is going on, like in a C++ error or something. And I always make sure I understand what it's saying, and if it spits out code, I never copy and paste that code. I always see if I can understand what's going on in that code, and then I fix my own code with that new knowledge. So believe me or not, literally all the code that I've written has never been AI generated. My Rebos video, why it's better than a bash. It should be pretty self-explanatory why Rebos is better than a bash script. Because Rebos has a diffing system. And sure, you could use the diff command in a bash script, but it's more janky. With Rebos, it's actually built around that. Rebos has a concept of managers and manager ordering. It has a concept of hooks. It has diffing, so if you add or remove an item, it will show up in the diff. And Rebos can keep track of that. And Rebos also has generations which are actually just snapshots, and you can roll back to certain snapshots and rebuild those snapshots and stuff. So Rebos is essentially just a post-install bash script, but instead of being a one-shot thing where you run it and then you can't maintain your system with that same bash script, Rebos is you run it for the first time, it installs everything for the first time, but when you add new things on like another machine or something, you can pull those changes into your Git repo or whatever you're using to store your Rebos configuration, make a new generation with Rebos, and then maintain your existing system with Rebos by installing those new packages, uninstalling old packages and stuff. I sync all my package installations between my machines using Rebos. That's why I made it. So I think maybe you misunderstood. AI generated code is not always garbage. Most of the time it is, especially when you ask it to generate like C code or something. The problem with AI generated code is morality and comprehension. AI generated code, if you just copy and paste AI generated code, you're not going to understand shit. And then you're going to be confused as to why your program doesn't work, and you're not going to know anything about it. You're going to be like that contributor trying to make a pull request, but it's your own project. So you have to familiarize yourself with a code base that you did not write. It's like you have dementia. So that's the issue with AI-generated code with comprehension. But morality, AI-generated code is just code laundering. It's morally wrong. Also, AI-generated code, which do you feel more satisfied by? A program you wrote yourself that works, or a program that you wrote with AI that works? Which would you be more proud of yourself with? I would think you'd be more proud writing all the code yourself. Well, Maddox, I guess you're weirder than me. Yeah, exactly. Okay, good, Maddox. I'm glad you're joking. CTX save register manual. CPU memory error. Register value. CPU registers general GP reg. Register size. See, this is... Oh, wait. Okay. It's just size of... It's just 8 bytes. Or size of uint64t. Size of uint64t, and then offset will be... Yeah, you know what? I'll keep it like that. Offset will be... Offset will be GP reg times size of uint 64t. The copy. Yeah, I can kind of tell by your like using NixOS, your profile picture and name. You can kind of tell. Hello, El, how's it going? Also, for context, my name's Jackson, and he knows that. Because he's a sly little stalker. So it's fine to use AI to understand an issue. It's not okay to use AI to solve the issue for you. Also, yes, my last name is Novak. You can find it on my GitLab. Actually, I don't live in the West. Well, I live in the west of the world, but I live in the South, bruh. Get it right. Hey, don't insult my name. Don't insult my name or I'll pull out my Texas branded gun. Let's see. Well, you don't use Nick's profile pic, but your profile pic, it's super... Profile picture theory is kind of hard to explain, but like, just based on the over energeticness of your profile... Ooh. I see a MAGA hat and I get happy. Just based on your overall profile picture, demeanor, And the fact that you're literally wearing a hat and headphones like that, like I can just from being on the internet for long enough, I can tell what kind of person you are just by looking at your profile. Kind of curious, what are these shorts? Okie doke. Yeah, I mean, your internet demeanor is way too, I'm a very calm person online, usually. So, yeah, your internet demeanor is a little much for me, but yeah. I can tell what kind of person someone is, usually just based off their profile picture and name and stuff. Like, your name's all in caps. And it starts with a Z. Okay, so first I save general purpose registers. Reading a book? What book? Sounds fun. Switch your nerd account? You do you. Frick, what am I doing? For uint8 ti equals 0, I is less than 10, I should actually define something. Num gp registers. So I should do that, and then I'll do ctx save register general purpose CPU memory error I. And if memory error equals 0, no, if memory error is less than 0, return. I don't remember if you mentioned, are you using a custom instruction set or utilizing a this is custom, completely custom. It's actually, I wouldn't mind if you rated my instruction set. So first off, I have my you know what? Nvim. So all right, so I have endianness, I have terminology, base, stack pointer, stack frame, jumping. I just explain all of this for the dead-brained. Calling, returning, instructions. It's not my name, but sure. You got my first name right, though. Yeah, I know that. Okay, so, Astro, I have somewhat dynamic sizes. It's based on the instruction family instead of the individual instructions. And here's my instruction table. I have halt, no-op, no-op I, which is where you can pass in how many clock cycles to waste. No-op R, which you pass in a register, which then holds essentially the immediate to know how many clock cycles to waste. I have load, which is pretty self-explanatory, where you pass in a register in memory. Load R, where the second register holds the memory address in it. Load I, which is where you put an immediate into a register. I have stir, or store, which stores values from a memory address into a register. Store R, which is basically store R. It's the same as load, but store. I have copy, where you copy the value of one register into another. Add, which you take LHS, RHS, and add into result. Sub, mul, div, inc, where you increment a register by one. Inc VI, which is where you increment it by immediate. Dec VI. I have jump R, which is where the memory address is in the register. Jizz, which is jump if 0. Jizz R, jump if 0, but with register. Jins, JNZ, which is jump if not 0. Jump if not 0 R. Jec, which is jump if equal, and it's where if these two registers are equal. Jec R, which is same thing, but the memory address is in this register. JNQ, JNQR, JIL, which is jump if less register. Jimmer, which is jump if more. I have BSL, bit shift left, bit shift right, bit rotate left, bit rotate right, bit and, bit or, bit XOR, bit not, call R, ret, push I, which is push immediate instead of push register, pop, syscall R, sysret, int call R, intret, end little, which is where endlit, where you change the endian of the CPU to little. End big, which is where you change the endian of the CPU to big. CTX load, which is where you load context. CTX save R, which is where you CTX save, which is where you save CPU context. CTX load, which is where you load CPU context. CTX save R, which is where you save only a specific register. CTX load R, which is where you only load a specific register. MMU on, which turns on the MMU, and MMU off, which turns off the MMU. And then I also have timer, which triggers the timer. And I also have all the descriptions down here too. That's my ISA. Yo, I have a challenge for you. How's it going at Debean, bro? Or Socks? Why do you call yourself NA? Who are you on Discord? Why? Just curious. Jizz. Yeah, I called it Jizz as a cum joke. Debean, bro. No autographs, please. Well, actually, I have 3 no-op instructions to stop bloat. Cause see, if you needed to no-op for 15 cycles, do you want to put down 15 no-op instructions? Do you want to set up a complicated loop? Because loops in assembly kind of suck. What about just no-op I 5? Or 15, actually. Alright, yeah, I want to hear your challenge. Yeah, I'm not trying Doom Emacs. I daily drive to Doom Emacs for a while. I daily drove Doom Emacs for a while. Well, I have Noppy and Nopper, which, it's for immediates and registers, so you can have more flexibility. Oh, you think my ISA is comprehensive? Might actually be kind of painful to write an emulator for, because see, like, this is comprehensive, but wait until you see in hardware. Okay. In hardware, registers can be split. So, if you type like RLLL3, it's register 3, least significant 8-bit selection of the least significant 16-bit selection of the least significant 32-bit selection. So registers can be split, which might be kind of painful to write an emulator for, but I think it's a necessary evil because split registers is actually kind of useful. Yeah, your instruction set, it's 8-bit, so you're bound to have some limitations. See, my instruction set is 64-bit because I actually plan on writing a proper operating system and stuff. CPU H. Define num GP registers 10. Num GP registers. There we go. C compiler transpiling assembly. I actually plan on making my own programming language. Maybe a C compiler too. Yeah, compilers are a lot of fun. That's cool. You're writing a cool CPU architecture that's unique. You look like a YouTuber. That's another thing. You can tell. So, yeah. You can tell when someone's a YouTuber based on their name and profile picture. Yeah, well, C compatibility, it's not, that's kind of a rabbit hole. Like, you could actually run Linux without a C compiler. Do you want to? No, but you could. I'm not forking anything massive or writing an LLVM backend. No, you keep asking me to do like these crazy, like fork QEMU to make the emulator. Why would I do that? Oh yeah, Unreal Engine. Yeah, I definitely want my operating system to be POSIX compliant. That's definitely important. Well, actually, I would say it's easier to write my own emulator from scratch because I know how to write an emulator and I don't have to learn someone else's code base and deal with years and years of cruft designed for other CPU architectures. Well, special registers. The most important Doom on it. Yeah. Well, I could do that without an operating system, most likely. Hell, I could do it without turning on the MMU, probably. Well, I don't think I'll be gaming on this CPU. Maybe, who knows? Like, also, I don't really do much gaming. I haven't really been creating my own editor. I don't know. I want to, though, but I've been kind of stunted by the fact that I just don't enjoy Rust very much anymore. Like, Rust is just going down. Rust is nosediving. Like, it was it's a good language, the language itself, but the community is just woke and just unbearable. Uh, the build system cargo is terrible for anything more complicated than a simple little Rust crate. Rust is slow to compile. It's statically linked. Like, they're doing dynamic linking in Rust is terrible. Like, no, I don't want to use Rust anymore. Rust actually infuriated me so bad, that's why I started trying to create my own programming language. Yeah, the Rust language is fine, but everything surrounding it is not so good. Also, the fact that I can use GDB with C code is amazing. Save all special registers. Oh, and I can do shit like iterate through all the elements of a C enum, because a C enum is just automatically setting numbers, which is super cool. For I is less than special registers. No, special register count. Special register count. I is less than. And then what I'll do is in cpu.h. Ooh. Define special register count is actually, I'm gonna do this as a static const uint8t special register count is how many special registers do I have? 2, 4, 6, 8, 10, 12, 14, 15. Let me count again. 3, 6, 9, 12, 15. Yeah, so 15 registers for 15 special registers. Then I want to create an enum. Type def enum special registers enum. And I want to put in here, I'm going to do spread IP, spread SP, spread BP, spread IT, spread ST, spread ER, spread IR, spread SR, spread IE, spread SE, spread CS, spread PT, and then spread PT, spread BS, spread BE, spread WA. And let me just make sure that these are defined in the right order. So I got IP, SP, BP, IT, ST, ER, IRSR, IESE, IRSR, IESE, CSPT, BSBE, CSPT, BSBE, WAWA. Good. So those are all the special registers. And then I should also, I'll set, I get kind of paranoid about this. So, wait. Yeah, and then these should just enumerate automatically. Yeah, C is really nice since I know how computers work. Rest was it's big C issue is anything string related. Yeah. Actually tested a code language made by my buddy. It's called Elslang on GitHub. Oh, cool. Yeah. I honestly, like, I might just stick with C for the foreseeable future because all the tooling is built for C and C++. Let me also make sure. Okay, 15. Number of special registers in ISA. All these special registers in ISA in definition order 2. Oh, web-based code. Yeah, I've seen a few of those. It's not web-based, but I've written, I was working on a programming language that compiles to brainfuck. Is there a way in, there's probably, is there a way in C to get the amount of items in an enum? Oh, cool, look at that. Oh, that's actually so smart. 0, 1, 2. Dude, that's actually super smart. So, special register count. Convert English into C++. I mean, people keep saying they would love a programming language where you just type in English and it just understands, but honestly, I would hate that because that's way too high level and way too up to interpretation. I like how rigid programming languages are because you can tell it exactly what to do. COBOL. Ooh, Python to C++ now. I can see how if Mojo didn't exist, that would be pretty hot. A little C trick I learned. Let's not mention the AI. That's actually so cool, though, that, like, just using a simple little AI query, I learned a cool little C trick. I should also, I'll make a lookup table. Wait, can I do weird shenanigans like this? Static special register sizes will be static uint8t will be can I literally pass in? Oh, I love C. Oh, I really love C. See, now this is something you really can't do in Rust unless you have some weird procedural macro type shit. So 64, and I have 5 64s, and then I have an 8, and then 2 64s, and then 2 8s, and then 5 64s. And just to test, oh, it works, boys. It works. Boys and girls, I guess. I need to say that before all the liberals come and flame me. 3, 6, 9, 12, 15. And no offense to any liberals in the chat. I'm not a liberal. Alright, see you, Noah. Have fun. I'll see you in the next stream. Right, I will need to go eat dinner soon. I already have the punishment of cleaning everything up. But I want to write an emulator. Okay, so lookup table with all the sizes for the sizes in bytes. Actually, I may have screwed this up. In bits. Oh my god. Why? In bytes, please. Bytes. Select 64. Actually, I want to do 8 first. I'm going to change that to 1. And then, oh, that's not what I meant to do. And then I want to spawn multiple cursors and select 64, 8. So IP is 8 registers, SP 8 registers, bytes, 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 ER, bytes, 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 bytes. Yep, okay. And now I just gotta... Yeah, so this is actually not Vim, this is Helix. And Vim can't even do that really as cleanly as Helix. Because, see, Helix can handle multiple cursors, whereas Vim cannot. A lookup table with all special register sizes in bytes. I guess I could format this too. There we go, formatted. Looks like I learned about a new text editor. Thanks for putting me on it. Yeah, no problem. It's basically a really minimal text editor written in Rust, and it just works. Like, it has built-in tree sitter support and stuff, and it's basically plug and play. And the configuration file, dude, the configuration file, it's insane how small it is. cd config helix config.toml. Look at that. That's my entire configuration file. Let's see, hardware, I want to make sure in bytes, special register, in bits. Why am I doing this to myself? Yeah, okay, size in bytes. Good. Fine. Yeah. Oh, we love to see it. Yeah, I'll probably try it off camera, just because it's probably a rabbit hole. Legs. I love my legs. Don't worry, guys, he's black. But for real though, let's maybe keep it out of the YouTube chat. Yeah, but like YouTube doesn't know. I'm glad you think so. I like my community a lot. Oh, well, see, now he's gonna boom. I like trains. Boom. See, now all of a sudden I'm just gonna see a notification pop up and it's just gonna have the N-word. Get ready for it. Yep. So predictable. And it's predictable because there is a stream delay, even if it's kind of small. Don't worry, guys. He's saying that playfully. Special register count. CTX save register special. I think if there's one person I don't want to scare away with my chat, it'd be Astro Sam, because he's actually like one of the OG reasons I got into CPUs. So Oh, why am I writing this here? I want CPU. Memory error. I. Save CPU context. Only specific special register. Only specific special register. Static inline void ctx save special register. ctx save register special. And I would pass const CPU restrict CPU int restrict memory error and gpreg, or in this case uint8t, or no, special register is enum register. Oh, wait, what? Huh. I wonder what that keyword does. Switch. I'm gonna massive switch statement. Special register. And I want 15 cases. 6, 9, 12, 15. Spreg. Excuse me. I want IPSPBPIT, IPSPBPIT, IPSPBPIT. I want STERIRSR, 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 IESECSPT, IESECSPT, BSBEWA. BSBEWA. And then I want my break statements. Ooh, I'm gonna write a macro. Oh, that definitely did not work. I guess here's what my macro will be. So I'll paste this macro. There we go. All with one keystroke. And break. I love the C switch statement. uint8t size special register sizes special register. And then, right, so I have the special register here. Hold on a sec. I don't think I even need a switch. Holy crap. Okay. I have an idea. Size. And then, just, holy crap. Okay. No, I need the switch. Okay. I'm gonna write a thing. It's gonna be never mind. No, actually I'm curious as to whether or not this will work. Static inline void special register PTR const CPU restrict CPU, and then I want to pass special registers enum special register, and then I want to switch this massive switch statement, and it will just get bigger and bigger from here. I'm glad you like it. Yeah, I'm definitely gonna keep this up. Let me just make sure. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Good. And then I need return CPU registers special dot v yank, and then yeah, there we go. And I want to return a pointer. Void return null. Just wait and see. He'll start another project and forget this one like it. Nah, this is like this is one of my dream projects though, and unlike my voxel game, which is my other dream project, this one's actually like more achievable right now. So I don't see myself abandoning this. Game Boy emulator. Yeah. There's a guy in my Discord server named Velu who's trying to do a Game Boy emulator. Okay, so that is switch statement that returns pointers to... I hope this doesn't do some weird, like, copy the value of this and then return a pointer to that I hope that's not what this is going to do. Return pointers to special registers in the CPU. Warn, returns null if passed invalid register ID. invalid special register enumeration enum variant. There we go. Beautiful code. Seriously, just the way C code looks is severely underrated. C code is actually super beautiful. I love the syntax. Size, void, PTR, special register PTR, CPU, special register. So that will get me a pointer to the special register. And then what I need to do is I need to is this approach for getting the offset slower? Yes. But is it less error prone? Absolutely. I want to say for address T offset equals 0. And then what I want to do is for address Ti is equal to, or actually I think I want to use size T for this one. Size Ti is equal to 0, I is less than or equal to special register, I think. Yeah. And then what I want to do is offset equals special register sizes plus equal special register sizes I. It shouldn't be too slow either, because there are not many special registers. Right, so that will get the special register offset. And so like saying special register is ID 1. Yes. No. I need to do less than. So if special register ID 1, right, so yeah. Yep, okay. So that will get the offset in memory, and then ctx save register manual CPU memory air and register value. Thanks for that information, Maddox. Let's see, what should I... Oh, how should I do this? Oh, I know. I'll write another function called static inline uint64t get special register value from PTR. Const CPU restrict CPU special registers enum special register. Yeah, that's true though. Get special register value. I need to first special register PTR. So I can just copy this. And I think the compiler will optimize any duplicate calls away, so it's fine. I just want to do it like this for safety reasons. Right, so now I need to make a uint64t. And I need to say, so value, dang it. Shower thoughts, give me your craziest. I don't know. Your mom? Yeah, I don't know. How about the fact that your DNA material is going down the drain and it's free for all once it leaves the drain? Size 1, case 1, break. I'm going to do value is equal to uint8t pointer ptr dref. And then if 2 uint16. If 3, if 4 bytes uint32 ptr, and then if 8 bytes uint64 ptr, and then default will be uint64 break. There we go. And I'll put some spaces too, just to make it look a little nicer. So that will be how I can safely get the value of a special register. Get special register value. Size offset. special register. Does that mean PTR goes unused? Okay. Okay, cool. So oh, I need to pass CPU. Yeah. Okay. And that should be it for saving special registers. I could also create another function, which would be no. Okay. So ctx save special register, and then we need to save all the flags. Okay, here's what I'm gonna do. I'm gonna go eat dinner real quick and then I'll be back. Just hang tight, listen to the music, enjoy yourselves, and you'll hear my voice when I'm back. Okay, I'm back. It took a little longer than expected because they also made me do all the chores and clean up after dinner. I wonder who's still in the stream. So, another thing I had was, like 6 people. I mean, that's pretty good for my streams, actually. But the thing is, that's not the real number. I don't even eat Thin Mints. But I'm probably the kind of person who would enjoy mayonnaise on Thin Mints. I love mayonnaise on everything. Also, hi, Bubbo. You're new. I haven't seen you in the stream before. I know how I can save flags. Special register. Yeah, okay. I can save the flags as CTX save flag manual. I'll save the flag as, instead of save flag, I'll do save flags. And then what I'll do is I'll do for U and 8ti, or yeah, I U and 8t flags. Memory error is equal to memory write CPU memory begin write to and then or target or store at and then flags store at plus offset. Looks like I have to go do chores again. Oh, okay, finally I'm back, and I think I'll be able to actually stay. Cool. I is, flags enum. Flag count. And then I need my flags in here. I need flag overflow, flag jump, flag big, flag MMU, flag halt. Overflow, jump, big, MMU, halt. And there are 5 flags, which is good. Flag count, yeah, so flag count, and then I++. Bool flag PTR equals get flag PTR. I just want to see, what did I call special register pointer, flag pointer. Yeah, flag pointer, and I pass in I. I also want to pass in CPU. Get pointer to CPU flag. Well, I like this song. Of course I do, it's Stardew Valley. Static inline static inline bool pointer. I want to do flag PTR and const CPU pointer restrict CPU, flags enum flag ID flag. Switch flag, and I'll also add that same warning. Returns null if passed invalid flag enum variant. Returns null if passed invalid flag enum variant. Case flag overflow return. Actually, I'll just write them all out first. A little bit of magic. Case case return CPU flags copy. Yank, paste, lowercase. And then I also want to align these. Bool pointer. Okay, I really do have to look this up. In C, if I pass a pointer to a struct and then I dereference and then I get a field from a struct from the struct and I make a pointer to it, will it actually point to the original struct field or a copy? Example. My struct value field 1. When you take the address of a struct field using it returns a pointer to the... Okay. That is good. Good. Okay, so this should work just fine. Overflow jump big MMU halt. I also need to make sure that's the actual overflow jump big MMU halt. Good. All the flags, in ISA. Return null. Okay, so there we go. Flag PTR. What is it complaining about? Oh. Flag PTR. Get flag PTR. Get flag PTR. Get special register value. CTX save flags. So go through there. Okay. Flags. I want to do flags is equal to flags. Okay. uint 8 t in byte as byte mask. Flag PTR, it will be flag PTR equals true. There we go. And that will return a little thing. And then I want to do shift it over by I. No, but I want it in big endian for expansion purposes. Flag count minus I. How about that? Let's see. So flag count, say there's four flags. If I is 0, I want to shift it over. No, let's say there's 3 flags. If I is 0, I want to shift it over by let's see. Shift it over by if I is 0, I want to shift it over by 7. Flag count is 3. Oh, okay, I don't even need flag count. I just need 8. Or size of flags times 8. So I want to shift it over, right? Hold on, why am I so confused by this? I shouldn't be. I want to, so here is the 1. Shift it over by 1. 1, 2, 3, 4, 5, 6, 7. Yeah. Okay. Yeah. Okay. Yes, okay, so this should work. And then flags equals flags as byte mask. Actually, I could just do this all in one. No, I'll do it like that. I'll make a function called pack flags. Pack flags into integer. Into bytes. Pack flags into bytes. Static inline uint 8t pack flags. Const CPU restrict CPU, right, and then I want to yeah, pretty much. Right, so I'm making a uint 8t with the flags. Good. Return flags. uint 8t flags pack flags. CPU, CPU. Yep, okay. Save, register, manual. Offset. Address T offset. Offset plus offset. Yep. Okay. Get special register value. CTX save register special. Address T offset. There we go. CTX save. Offset can be 0. And then offset will be num. Offset will be num GP registers times size of uint 64t. Yeah. Okay. Actually, I should make an offset address T offset 0. Offset plus equals num GP registers size of uint 64t. Offset, and then offset plus equals Oh, you know what? I could, yeah, I'll do, offset plus equals special register sizes. Oh. Error prone. It's not the full context though. Is this approach for getting the offset slower? Yes, but is it less error prone? Absolutely. So it's less fun. But yeah, let's cut off like that. Error prone? Absolutely. Yeah, that's awesome. I should also do this check. I'll put that in there for cleanliness. There we go. Actually, no, I can't do that because this automatically calculates offset. Wait, hold on a second. CTX save register special. Oh. I don't think I need this function. Actually, no, I should leave it. But I can not use it. I can just not use it down here. Interruptions. Right, okay, where was I? Save register manual. CPU, memory, error, register value will be, get special register value CPU I special register sizes I offset. There we go. Honestly, I'm thinking. What if I just, well... Wow, I'm glad it looks like a bull fart, I guess. Offset, yeah, because I like this cleaner aesthetic. Why you call it bullshit? You just don't understand it. Let's see. Save all. Okay. Yep. Save flags. Save all flags. CTX save flags. CPU memory error offset. And then this check just for sanity. Obviously the compiler will optimize this out, so it's fine. So I believe that's context saving implemented. And then for context loading, I need to kind of do the same thing, but I'll change things around a little bit. Hello, Helix. What the hell is going on? Oh, I have caps lock on. Classic. So load and CTX load register general purpose. Or actually, this one might be even simpler. It's just a CTX load register manual. Because I have save. Yeah. Load register manual. It'll be CPU. Memory error. Or just memory error. And size of uint 8t and offset. And then special registers will be CTX load register manual, CPU memory error, CPU memory error, load register manual, CPU memory error, special register sizes I offset. Yeah. And then CTX load flags. So now I just have to write these functions. And I'm going to write my specification before I forget. All multi-byte values are stored in little endian, no matter the CPU's configured endianness. All multi-byte values are stored in little endian no matter the CPU's configured endianness. Flags are stored in a single byte where each bit going from most significant to least significant is the value of the flags in definition order. So for clarification, the first flag defined in the ISA will be stored as a 0 for false and a 1 for true at the most significant bit of the byte. So big endian just on a bit level. There we go. What's a Chris vector? That does sound kind of familiar, though. Ah, nice. Yeah, my brother would love that. CTX load register manual. Load register to context memory chunk with manual address byte offset from chunk start. And then static inline. Honestly, I don't need to inline it. Static CTX load register manual. Const CPU. Restrict CPU. And then I want int restrict memory error. And then I want uint64t. I want uint 8t register size. And then address t offset. And then I guess I could copy all of this. Load from And I instead want to, for address TI 0 less than register size I plus plus. Let's see, I think I want to do something slightly different. I want to do a memory uint8t byte. Actually, it's int byte equals memory read CPU memory load from plus I right, and then physical address is oh wait, what? Oh, okay, that's fine, that's good. And then if byte is less than 0, memory error equals byte and return. I need to remember to set these memory errors. Memory error. I'm trying to save up for the sine lens set that costs $3,000, so I'm just struck with envy when people buy expensive things right now. Oh, right, yeah, because you like photography. Byte or error. uint8t byte or error. Right, so just to review. All multi-byte values are stored in little endian. Yep, okay. So I'm at the least significant right now. uint64t value. uint64t mask bit mask. It will be uint64t byte shifted over by I. Yeah, so if I is 0, that means we're getting the most significant. And I also want to times this by 8. Yep. So, okay. I hope I'm doing that right in my other code too. Yeah, see, I don't think I am. That was close. Byte register value. Yep. Value equals value bit mask. Bits. Bit mask or. And then this can go. Wait, no, I need to, yeah, okay, this can go. And now I just need to return, or no, yeah, I'm just gonna return it. Read register to context. Load read register from context memory chunk with manual address, byte offset from chunk start. Oh, I really want a 3D printer. Honestly, even though it's possible for me to have the money for it right as I finish college, I'm probably just gonna wait till I've got a job. I spend what I have now on a CPU upgrade or something. Yeah, I kind of want to upgrade my CPU because I got mine like right before CPU technology just shot through the roof with performance. Like, there are people who can compile the Linux kernel in like 3 seconds, and it still takes me, what, like 20 minutes to compile the Linux kernel? So, yeah. Bitmask or bitmask or return value. Yeah, 3 seconds is kind of nuts to compile the Linux kernel. Like, it takes 20 minutes and I've got a very good computer. Okay, so I'm reading the register. Okay. Yeah. So CTX read register manual, CPU, memory error, Oca64T value. CPU registers general I is equal to value. Read Oca64T value. Set special register value. Get special register value. And then I'll use this as a basis. Set value the hell were they even doing it on? Like a thread ripper or something? Explain what... Yeah, probably a thread ripper. Explain what is going on in Dodo terms. So in Dodo terms, I'm implementing CPU context loading. AKA, after you save your CPU state, you can load it. This is how operating systems do task switching without corrupting program memory. Get special register value. I want to set special register value. So I guess copy this. Set. And then CPU, restrict CPU, special register, and Oca64 value. Void. uint size, special register sizes, PTR. Okay, switch. Right. So I could, I think, first off, I just want to remove this. And then I want to go to all of these and say value doesn't equal u equal value. Imagine trying to avoid corrupting memory. Pathetic. Live life on the edge for once. Well, it's not so much corrupting memory. It's the fact that if I dereference PTR as a uint64t, there's a chance that I crash the entire program, not just corrupt memory. CTX save, CTX load. Time to CTX load flags. CTX, where am I saving flags? CTX save flags. Static inline void CTX load flags. Have you update your kernel? No. Well, yes, I think I did via Gen 2 system update, but I use bin hosts, and that includes bin kernels. But I did compile the Linux kernel once, but it's just, I don't know, I just wanted to see how fast it'd be. CPU restrict CPU int restrict memory error, and address T offset. And I also want to set, okay, that's fine. Static inline void CTX load flags. Address T load from CPU registers special CS plus offset. uint 8T or actually flags unpack flags. CPU flags equals flags. CPU flags is equal to unpack flags. And I'll do flags uint 8T, or actually int byte or error is equal to memory read. CPU memory load from if byte or error is less than 0, memory error equals byte or error, return, else uint 8T byte equals byte or error. Byte. I'm compiling the kernel right now just to see how long it takes. Not ideal considering I've got Florp. Yeah. Oh, yay, Florp. Let's go. I believe that's all I need to do for that. Now I just need to write this unpack flags function. Static inline flags unpack flags. Unpack flags from bytes. From byte. uint 8T flags byte. Flags. Let's see. You know what I'm going to do? I'm going to make a mock CPU in here. I'm going to say CPU dot flags is equal to memset CPU flags zero and flag count times size of bool. Beautiful. Mock CPU dot flags. Yep, mock CPU. Mock CPU dot flags. Flags, 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 flags. Now, I got the flag pointer. Unpack flags. Flag count. I need to uint bit equals flags byte shifted over by let's see, size of uint minus I. So like if I'm dealing with the first flag, yeah, like overflow, then I want to I could be making a mistake here too. As byte mask flag PTR, not by bytes, by bits. No, yeah, by bits. But yeah, okay. Times 8. So if I'm dealing with the first thing, I want to shift it over. Well, wait, what? I'm not your dad. Not yo dad. You're literally older than me. By 1 year, but you're older than me. Oh. Yeah. Let's see how that goes. Took you 3 minutes to compile. Oh wow, okay. My CPU must be worse than I thought. What the frick? Or maybe I'm getting it confused with something else. Because my CPU is fine, I think. No, my CPU is actually really good. It's top of the line when I got it. Like top of the line Ryzen, so. One sec. I got think that's probably, it seems familiar. Also, I think my Rebo's config. Yeah. Yeah, so, I got, it looks like, AMD, yep, name, AMD Ryzen 5900X, 12-core processor, microarchitecture Zen 3, technology 7nm, max frequency 4.9 gigahertz, cores 12 cores, 24 threads, AVX, AVX, AVX2, FMA, FMA3, L1I size, yeah, okay, peak performance, 1.9 teraflops a second. Dude, I just focus on how this stuff works under the hood and the software. I have no idea what half of that means. Bit. Okay, bit, yep. And then flag PTR. Yeah, you're on a much better CPU than I am. No clue how it'd take longer for you to compile the kernel unless you're just thinking of some... Maybe I'm like compiling it in release mode if that's even a thing for the Linux kernel. I have no idea. 'Tis strange. Bit flags byte. Okay, flag PTR. I believe that's all I have to do to unpack flags. Yep. CTX load. So I believe that's context loading. Now. Oh, here's that go to, and also the well, we're screwed. Actually, can I handle this? Because, let's see. Yeah, it kind of just can't handle this. CPU advance. Okay. CPU execute. next instruction address. Fetch instruction, full size instruction size with opcode. Current instruction. Fetch instruction. That's what I need to do. So int memory error. Instruction. Instruction equals fetch instruction CPU memory error CPU registers special IP. If memory error is less than 0, I need to make a function. I need to make a function that's like a CPU process memory error as CPU. CPU memory error. So, process memory error as CPU. CPU memory error. Void process memory error as CPU. Const CPU restrict CPU. Int memory error. Paste. No. Right, can't be const. Break. There we go. Noise. Now I need to switch on a instruction.opcode. Case. Time to pull out all the frickin' opcodes. Get ready for this. Halt. So opcode opcode 000 is halt, and then we have NOP, which is case 0001 break. And then there's a NOPI, which is case 02. And then NOPPER, which is case 03. And then load, case 01, because it's a new instruction family. Break, load R, which is case 011, break, load I, case 012, break, stir, which is case 013, break, stir, which is case 014, break, and then stir, we have copy, which is 15. Copy add, which is case 020. And then sub moldiv, add sub moldiv, inc. Okay, time is running out. My dad's about to cut off the internet. Inc. $34. Wait, what? Oh, that is a mistake. There we go. F. Oh, F. Inc is 30. Inc VI is case 31. And then dec is case 32. Dec VI case 33. Jump, which is case 40. Jump R, which is case 41. and then jizz, which is case 42, jizzer, which is case 43, and then gins, which is case 44, and then ginzer, jizz and jizzer. I did that on purpose. And then after ginzer is jack. Ginzer jack is case 46, and then jecker is case 47. Jenk is case 48. Jinker is case 49. Wait, what? Hold on, what just happened? Oh. Yeah, Jecker 47, Jinker 49. Yeah, okay, we're all good. Oh god. Oh, I called it jizz because there's no such thing as a good computer project without at least one dirty reference in it or swear word. And then Jill. Jill, case 4A. Yeah, 4A. And then break. Jiller, case 4B, break. And then Jim, case 4C, Jim 4C, and then Jimmer 4D. And then BSL 50. BSR, case 51. BRL and BRR. '51, and then BRL and BRR. BSL, BSR, BRL, BRR. I mean, true. I remember grepping the Linux kernel source code for fuck, and I think there's like 12 fucks in the comments. Yeah, exactly. Drivers for Sun Microsystems. Yeah, that makes sense actually, just intuitively. BRR, B and B. Yeah. Okay. So. B and B and is 54. B or is 55. Yeah. Oh, what did I do wrong? Oh. I knew something looked off. B or B XOR case 56. B not 57. What editor is this? Helix. Also, welcome to the stream. I've not seen you in my streams before. Welcome. Sidthu. B not 60, and then call. Call will be case 60. And then call R is 61. And then ret is 62. And then push is 70. And push I is 71. Pop is 72. Syscall is 80. Syscall R is 81. Sysret is 82. Sysret is 82. Int call is 83. Case 83. Int call R is 84. Int ret is 85. Yeah. Oh, almost done. 85. Break. Int ret 85. And then we have endlit and endbig. Endlit case 90. Break. And endbig case 91. And then we have CTX save. Yeah, okay, so CTX save case A0 break CTX load case A1. Yeah. And then CTX save R is case A2, and CTX load R is A3. And then MMU on is B0. Case B0. MMU off. Case B1. And timer is C0. CTX save load MMU on, MMU off, timer. Yeah, okay. And then at the very end, I want my default case to do trigger interrupt for invalid instruction. Trigger hardware interrupt. So these are all my instructions, and I'll put spaces in them to make it nicer too. Select. Ooh. No, I just broke my selection. Okay, I'm gonna record a macro. There we go, much faster. A little too fast. Select timer, or no, comments. I want to put them down a little bit. There we go. Now each instruction has its own little dedicated space. Okay guys, I'm gonna wrap up the stream now because my dad's about to turn off the internet, so I hope you guys enjoyed. Alright. See y'all. Bye-bye. And does it make? Yes, it makes. Let's frickin' go. Yay. Yes, I was locked in, and hide, I'm assuming MAGA's alt. See ya. Alright, bye-bye. Bye-bye. See y'all next time. I just know these things. Alright, see y'all. Bye-bye. 3, 2, 1.